Okay, the reason we wanted to talk about interval notation is because we're now going to use interval notation to represent domain and ranges of functions. So remember from the very first video of the unit, we talked about what is a function, and then we talked about the domain of a function, and those were all the x values that a function could be evaluated at, that you were allowed to plug into the function. And then we talked about the range being all of the y values that the function could get out. And when we just had ordered pairs, it was very easy to list just all the x's and list all the y's. But what about when we have a graph? So let's start with this first graph. We've got this, it looks like a cubic function, okay, something with an x cubed. And it's going down forever this way, up forever this way. And to think about domain, think about, walking along. So let's say you were walking along the x-axis and you were looking up and looking down, and you just wanted to know where was the graph above you or below you as you walked along. And here we kind of have to remember that this is going on forever down and this is going forever up. So as we walked along, we would actually have graph above us or below us everywhere, all the way from negative infinity to infinity. So the domain of this function would be all real numbers, or negative infinity to infinity. Now, the range talks about what y values. So if you started down at negative infinity and went up, where was there a graph that had that y value? And here we see it's going to go all the way down to negative infinity, and it's going to go all the way up to positive infinity. So our range would also be all real numbers, negative infinity to infinity. Okay, now let's look at number 2. Number 2, definitely doesn't have as big of a domain and range as number 1 did. Okay, it has a definite starting and stopping point. So we'll see if we were walking along here, okay, there's no graph above or below us, right? Nothing here until we get to 2. And the graph kind of starts along the x-axis at 2. And there is a point at 2, so we're going to use a bracket and we're going to say the graph goes from 2, and we keep walking, and the graph stops at the x value 6. So the graph goes from 2 to 6. After that, there's no graph. Okay, the range, well, we want to go from bottom to top. So down here, there's no graph. The graph doesn't really start when we're going from bottom to top until 0. We go to 0, and the highest point on the graph is 2. So it stops at 2. So our range goes from 0 to 2. Okay, number 3 is very similar to number 1. We see that the graph goes in either direction. We've got arrows, that means it's going to go on for negative infinity to infinity. There's no parts where we're jumping or skipping or leaving anything out. So our domain is from negative infinity to infinity. And the lowest the graph is going to get, it's going to keep going down, so the lowest would be negative infinity. And if we go up, it's going to keep going up, so the highest would be infinity. So the range is all real numbers as well. Okay, let's look at number 4. Now number 4 is different than any one of we've seen because we do have the arrows going to the left and to the right, meaning that the graph will continue on. So we have a graph, if we're traveling along the x-axis, we've got a graph, it's kind of leveling off, okay, and it goes down to negative infinity here. And what's important here is we don't have an x value at 2. And we'll talk about this later in the course, but that's actually called a vertical asymptote. So we have to leave out 2. But then after 2, it's going to go on and go toward infinity. So here's a case for the domain. We want all numbers except 2. We're leaving out 2. And I talked about it in the last video how to write that out. We're going to go from negative infinity up to 2, use a parenthesis, union 2 to infinity. Okay, now we need to look at the range. So we're going to look from bottom to top. So when we start here, this is going down to negative infinity. So we've got range from negative infinity all the way up. Well, here we see that it never actually touches the x-axis. It never touches 0. But then after that, the graph starts happening again, and it's going to go all the way up to infinity. So for the range, we want all numbers except 0. So we're going to write that as negative infinity to 0, union 0 to infinity. Okay, so remember for domain, you're going to look from left to right and find where does the graph appear. And for the range, you're going to look from the bottom to the top to see where the graph appears.